Okay, now we will learn how to solve a homogeneous equation. So what is a homogeneous equation actually? So first you need to know the general form of the dy dx. It looks like this. Okay, so this dy dx is equals to fxy, right? So here is the method of the solution. First, you need to show that it's homogeneous. Okay, it's homogeneous. How? How to show that the equation is, the differential equation here is homogeneous? So here we have fxy, meaning the functions is in variable x and y only, and then we need to substitute x with lambda x, y with lambda y. Okay, and then we simplify it, and then in the end we will get the answer is equals to the original equation here. Okay, so that's when we say that it's homogeneous. So if we start, next is the method to solve it. We start with substituting y is equals to xv, and dy dx, here we substitute with x dv over dx plus v. So we substitute in this general equation, the given equation. So next is we separate variable x and v to form separable equation. Okay, from number 2 we will have to separate x, okay, and v normally we separate v on the left hand side, x on the right hand side. Okay, make sure only x on the right, only variable v on the left. Next is we can solve the separable equation, because when we separate the both variables, it becomes a separable equation, and we can solve the equation using the method we have used for separable equation, which we have learned in the previous subtopic. Okay, and then after we have solved the equation, we need to substitute v is equals to y over x into the solution. Okay, and then we simplify the solution. Okay, that's it. So here, let us take a look at this example. Okay, let us do this together. So remember, the first step is to substitute the x with lambda x and y with lambda y. Okay, so we set f lambda x lambda y and prove that is equals to f x y. And then next we substitute y is equals to vx or xv, and then dy over dx we substitute this as equal to x dv over dx plus v. Okay, so first of all you need to make sure it is in the general form like this: dy dx equals to fxy, a function of x and y only. So the first step, okay, you find f lambda x lambda y, so it will be 2 lambda x lambda y plus 3 lambda y squared. Okay, so we substitute x lambda x to each x, and lambda x squared plus 2 lambda x lambda y. So it's become like this. So it will be 2 lambda squared xy plus 3 lambda squared y squared divided by lambda squared x squared plus 2 lambda squared xy, right? So now each term, okay, each term, this term have lambda squared, this term have lambda squared, this term got lambda squared, this term also have lambda squared. So meaning we can factor out the lambda squared. If not, we cannot factor out. We must got lambda squared to each term. So then we can cancel it out. Okay, we can cancel it out. So in the end, it will be 2xy plus 3y squared divided by x squared plus 2xy. So this one, okay, if you look carefully. So this is exactly the same as the original equation given. Okay, the general equation given. So here we can write as f x y, okay, because it's the same. So we say that this equation is homogeneous. Okay, homogeneous. So we can proceed with the next step on the method to solve for homogeneous equation. So how to solve for homogeneous equation? Okay, we have proved it. Next is we need to substitute with this one. Okay. So dy dx will be x dv over dx plus v. Okay, it's not a capital V, this is v here. And then 2xy, okay, xy you should substitute with vx, so it will be 2x times vx plus 3vx squared. Okay, divide by x squared plus 2x times vx. Okay, as you can see here, vx, y here substitute with vx, y squared here becomes v squared x squared. Okay, and then y here become vx. Okay, that's how we do it. So next is we are going to simplify it. So it will be 2x squared v plus 3x squared v squared divided by x squared plus 2x squared v. So the trick here is you will always can simplify it. Normally we can cancel out or simplify the x. We simplify it before we separate. It's possible to be x there, okay, it's still possible for x to be there. Most of the case is still there, but sometimes it's simplified. So here x squared is on each term, so we factor out x squared. Sorry, 3v squared. Now it will be x squared 1 plus 2v. So we can cancel out. So now the equation becomes x dv over dx plus v. So 2v plus 3v squared divided by 1 plus 2v. Okay, so now this is the second step where we substitute it. So next is we need to separate them. Okay, v we need to put on the left hand side, x will be on the right hand side. Okay, so what we can do is first we move this v, because it's already separated on the left hand side, so we should move the things that is already separated. Okay, so it becomes x dv over dx to 3v squared minus 2v divided by 1 plus 2v minus v. So now here you need to simplify it. Okay, before you move the x, let us make the equation on the right hand side become one term, as one term combined together. So it will be 3v squared minus 2v minus v times 1 plus 2v, right? Divide by 1 plus 2v. Is it correct? Yes, right? So next is we simplify it. So 3v squared minus 2v minus v, okay, minus 2v squared divided by 1 plus 2v, so it's equals to v squared minus 3v divided by 1 plus 2v. So here is continue dv over dx. So we can separate it now. Will be 1 plus 2v divided by v squared minus 3v is equals to dv here equals to 1 over x dx. Next is we can integrate them. Okay, how to integrate this? How do we integrate this? Okay, so you have to use your knowledge on mathematics 1 on how to integrate, okay, function. So now we just integrate left hand side and right hand side separately. So 1 plus 2v will be v minus 3. So dv is equals to 1 over x dx. So any idea how do we integrate this? So we can use partial fraction, right? So we solve for this one. It will be 1 plus 2v divided by v minus 3 is equals to a over v plus b over v minus 3. So we find for a and b, we solve for a and b. So it will be, okay, we let v equals to 0. So a negative 3a is equals to 1. So a is equals to negative 1 over 3. How about b? B we can let v equals to 3. So 3b is equals to 7. So b must be equals to 7 over 3. So you can plug in. So it's actually the integration of negative 1 over 3 over v dv plus 7 over 3 v minus 3 dv is equals to the integration of 1 over x dx. So what do we get here will be negative 1 over 3 ln v plus 7 over 3 ln v minus 3 plus equals to ln x plus c. Right, so you obtain everything here. So everything is in the norm, right? Okay, so next is we want to plug in the y over x. Okay, since y is equals to v over x, so v is equals to y over x. So we plug in here, will be negative 1 over 3 ln y over x plus 7 over 3 ln y over x minus 3 is equals to ln x plus c. You can stop here, you can eliminate the ln. Okay, or you can eliminate the ln. Okay, so let us solve this question. So we need to show that f lambda x lambda y is equals to fx. F lambda x lambda y is equals to f x y. So what is f lambda x lambda y? It is lambda squared x squared plus lambda squared y squared divided by 2 lambda squared x squared. So we can factor out the lambda. Okay, and then we can cancel it out. So in the end, what we will get is actually the original equation given here, which is equals to the f xy. So we can say that it is homogeneous equation. Homogeneous equation. Okay, so that's how you prove it. Now we want to solve it. So how to solve it? By substituting dy dx equals to x dv over dx plus v, and x squared with, okay, y is equals to vx. So x squared become x squared. This one will be v squared x squared. Next one will be 2x squared. So now we will cancel out the x, right? Okay, we can cancel it out here. So it's just left with 1 plus v squared divided by 2. Right? So we can move it. So it become like this. Now you can integrate them. Okay, for the first one, if we integrate, we need to use partial fraction, right? Okay, on the left hand side, it will be, or maybe we can just use substitution, right? So we let u equals to v minus 1. So du over dv is equals to 1. So the equation becomes negative 2 divided by u squared. dv will be du minus over 1. So it's actually 2u power negative 2 du, right? Yes, correct. So now we will integrate it. So when we integrate, we will obtain 2u negative 1 divided by negative 1. So which is equals to negative 2 over u. Negative 2 over u. So it's become negative 2 over v minus 1. We substitute back this one. So this is the answer for the left hand side, right? So we equate them together. Negative 2 divided by v minus 1, okay, is equals to, integrate 1 over x will be ln x plus c, right? So we can substitute what is y over x. V is equals to y over x. So this one is actually negative 2 divided by ln x plus c equals to v minus 1, right? So v is equals to 1 minus ln x plus c. So you substitute what is your v. V is equals to y over x. Okay, so 1 minus ln x plus c. So y is equals to x minus 2x divided by ln x plus c. So you can just leave it like this. Okay, that's it. Okay, now we are going to try to solve this exercise. So as you can see here, it's not in the general form that we want. Okay, it should be dy dx equals to something, right? But it's not. So what you need to do before you prove it homogeneous, you need to rearrange the equation so that, okay, this equation becomes dy dx equals to something. So you need to write in terms of dy dx. So let us try to do this together. First, maybe we can move the dx, okay, this one on the right hand side. So it's become x dy is equals to negative x minus y dx. So next is we will move the dx on, Okay, next is dy over dx is equals to, okay, this one is x, sorry, negative x plus y actually, right? Divide by x. Okay, so now it is in the general form. Now we can test for the homogeneity, or we test whether it's homogeneous or not. Okay, how to test it? We prove f lambda x is equals to f lambda x lambda y is equals to f x y. So let's try to do this together. So dy dx, okay, so f lambda x lambda y is equals to negative lambda x plus lambda y divided by lambda x. So we can cancel out the lambda. So be careful, sometimes they may want to test on your understanding, so it gives you a non-homogeneous equation. So meaning you need to prove it's not homogeneous. It's non-homogeneous, meaning you cannot cancel out the lambda. Okay, in that case it's not homogeneous. So now we know that f lambda x lambda y is equals to fxy, so it's homogeneous. So we can proceed with the finding in the solution. So what is the equation just now? It is dy over dx is equals to negative x plus y divided by x, right? Okay, so we substitute x dy dx is equals to x dv over dx plus v is equals to negative x plus vx divided by x. So now you can cancel out the x. So it's become negative 1 plus v only, right? So here is x dv over dx plus v. So now you move the v from the left hand side to the right hand side. Okay, so it will be equals to negative 1. So now we separate. Okay, x on right, v on the left. So negative 1 just be nothing, a number, right? So it can be on the x, it can be on the v. You choose it. So for me, I'll just put it here, okay, on the right hand side. So it's become like this. So when we integrate both sides, is actually v is equals to negative ln x plus c. So it's actually y over x is equals to negative ln x plus c. So y is equals to negative x ln x plus cx. Okay, very simple as that. Okay, last example. So as usual, you need to show this homogeneous equation. Okay, it's already in the general form here. So we need to prove that f lambda x lambda y, okay, is equals to fxy. So it will be lambda cube x cube plus lambda cube y cube divided by lambda x lambda squared y. So it's actually lambda cube x cube plus y cube divided by lambda cube x. This is x squared. X squared. So now we can cancel out, right? So it will be x cube plus y cube divided by xy squared. Okay, so this is actually equals to the fxy, where it is actually the original general form given. Okay, same. So we can say that this is homogeneous. Okay, homogeneous. So if it's homogeneous, we can proceed with the equation, solving the equation. So we will substitute y is equals to vx, dy over dx is equals to x dv over dx plus v. Okay, so dy dx, substitute in here. So x dv over dx plus v is equals to x, okay, doesn't change, v cube x cube divided by x times v squared x squared. So in the end we'll have x cube 1 plus v cube divided by x cube, okay, v squared. So we can cancel out, so we're just left with 1 plus v squared divided v cube divide v squared. Okay, on the left hand side it will be x dv over dx plus v. So now we focus on separating x and v. So we move the v first. Okay, always move the v first because it's already separated from the x dv dx there. 1 plus v cube divided by v squared minus v, and then we're focusing on the combine together the v term, all the v term. So it would be 1 plus v cube minus v cube divided by v squared. So what do you obtain here? X dv over dx is equals to 1 over v squared. So now we have only two terms, okay, only one term for both sides, so we can move them together. So it will be v squared dv 1 over x dx. So we can integrate this, so it will be v cubed divided by 3 is equals to ln x plus c. So it's actually v cubed is equals to 3 ln x plus 3c. Okay, so we substitute y cubed divided by x cubed. Okay, we substitute v equals to y over x. So it will be 3 ln x plus e, maybe e, where e is equals to 3c. Okay, that's it. We have this, or we can move it to the right hand side. 3x cubed ln x plus ex cubed. Okay, can stop here. So this is called a general equation, but it's given two conditions here where y equals to 2 when x equals to 2. So we need to substitute the value for x and y here, okay, and then we can have a particular solution. So x is equals to 2, y is equals to 2. So we substitute 2 cubed is equals to 3 times 2 power 3 ln 2 plus e 2 power 3, right? 2 power 3 is, so 8 is equals to 2 power 3 is 8. 8 times 3 is 24 ln 2 plus 8 e, right? So what was the answer for e? So we obtain e is equals to 8 minus 24 ln 2 divided by 8. So what's the answer? You can use your calculator. Negative 1.0794. So your particular solution will be y cubed is equals to 3x cubed ln x minus 1.0794 x power 3. So that's it. So here this example shows that when you are given a condition y equals to 2, x equals to 2 like this, okay, you need to find the value of the constant. For instance, here is e, e, c, d. So in your final answer will be no more unknown constant. Okay, must be only variables and number. All right, so that's it. So I'm going to skip on this. All right, so here are exercise that you need to do. Okay, we name it as exercise 1.2. So make sure you obtain all this answer. Okay, so the due date I'll give in the information to you later. Okay, thank you.